Hi, you guys. It's Mr. Vallejo. Here we are in the VRC Chemistry Lab. Today we are going over the questions on page 504 of our chemistry book. These have to do with chapter 15, which talks about the properties of water. And this one is called 15.2 lesson check. So let's do some of these together. I know you have just finished reading 15.2. So I hope that this will make sense now that you've done the reading. Let's take a look. All right, question number 10. I hope you have your chem book with you because I got stuff all over the place and if I try to, well, I'm gonna do it anyway. I'm gonna move my coffee over and get you the question. Here is, oh my gosh, here's the question. I gotta move this stuff over because now I gotta move the camera. All right. All right, here's the question. The question is 15.2. 15.2, number 10. And you can see all of them there. And if you want to take a screenshot, if you don't have a book, you can take a screenshot after I focus. And you'll have all the questions. There's questions 10 through 17. We're going to be taking a look at all of those today. So just give you a moment in case you want to take a screenshot or because you don't have your book or you just don't like your book and you want it electronically. There it is. I'll also post this in Canvas or our learning management system, whatever that may be. For some of you, it's Schoology. For some of you, it's Edmodo. So most of us are using Canvas. So there it is. And we're going to do 10 through 17. So let's take a look at number 10 specifically right now. Number 10 says, what types of substances dissolve most readily in water? And so the answer to that question has to do with the properties of water, actually. And the property of water that leads to all the other properties of water is the property of polarity. So the polarity of water also causes the hydrogen bonding. And so as water molecules associate with other molecules, the ability to form hydrogen bonds is going to play into how the water molecule is going to pull on something. So in words, I guess I could say that the polarity of water leads to hydrogen bonds. And because of the hydrogen bonding, now individual water molecules, because they have a partial positive side and a partial negative side, can pull on different chemicals. Well, what are those chemicals that they're going to pull on that will dissolve in water? Well, first of all, there's ionic bonds, or ionic, not bonds, but ionic molecules, or let's just say ionic compounds. The one we always use for you is sodium chloride. I'll say as an example, there's NaCl. But remember when we studied this before, we saw that sodium chloride is an ionic compound, and it's made up, when this dissociates, you have two ions. You have a positive sodium ion, and you have a negative chlorine ion, which are together. Remember in chemistry, like love, opposites attract. And so these guys are attracted to each other. But then when your water molecule comes and your water molecule's over here, here's a water molecule with a slightly negative charge there and a slightly positive charge there. But electrically it's neutral. The whole thing is neutral. Because this is ever so slightly negative, and this molecule right here is positive on this side, there's going to be some attraction there. And that attraction is the hydrogen bond. And so because now this guy is going to be pulled by this water molecule, and then many other water molecules are surrounding this, the sodium is going to get pulled apart from that chlorine. So that's an ionic compound. But also, we see that there are molecules like water that are covalently bonded, not ionic, but covalently bonded, but they're polar also. So let's say polar, how should we say this? Polar covalent compounds. Okay. Because they also have, they don't have separate ions like this, but they do have parts of the polar covalent compound that are partially positive and partially negative. So polar covalent compounds will be pulled apart as well. All right, so that's number 10. The answer is ionic compounds and polar covalent compounds. Hope you got that one right. Here's number 11. 11 comes after 10. And the question is, and hopefully you have your book, but it says what properties of all ionic compounds make them electrolytes? What property of all ionic compounds make them electrolytes? Well, what property is that they will they'll break up into water, and in chemistry we say that they will break up or dissociate into their respective ions. So that is number 11. All ionic compounds will break up just like this one did right there. Okay, associate in the ions for number 11. Okay, number 12. Why do hydrates easily lose water when heated and regain water when exposed to moisture? Now, if you remember, a hydrate is some kind of compound that has water molecules associated with it. It has many usually water molecules associated with it. But the question is, why do these hydrates easily lose water? Well, remember that those water molecules are held on much not as strongly as a covalent bond, stronger than a hydrogen bond, but still not as strong as a covalent bond. So I guess we could say that the forces that hold the water molecules onto that compound are weak. So let me write that. Forces that hold the water molecules are not as strong as a covalent bond. I'll just say weak. Forces that hold water are weak. So that's number 12. And so again, why do hydrates easily lose water when heated? Because they're not held on that well. And then why do they regain water when exposed to moisture? Because it doesn't take much energy to make that bond again. So that's number 12. All right. Let's go to number 13. 13 says classify, and it says identify the solvent and the solute in vinegar. Okay. Now vinegar is then a solution. Here's your beaker. And in vinegar, it's mostly water. Okay, so it's mostly water with a chemical in it. What's the chemical? The chemical right there is acetic acid. So it's mostly acetic acid, mostly water. So because the chemicals are dissolved in water, we say that the solvent in this case is water. And most chemical reactions that we study, the solvent is water. Sometimes it's alcohol. Sometimes in more advanced organic chemistry laboratories will need to use something like ethanol as a solvent. But for us, we in inorganic chemistry, what we're studying this semester, the solutions that we're going to have, this solution right here is going to have water as a solvent, and whatever's dissolved in the solvent is called the solute. So the solute is the acetic acid, and the solvent is water. So my cup of coffee this morning, it's coffee. We call it coffee, but it's mostly water, honestly, right? And so just your coffee and your sugar and cream, if you have that, is It, it's mostly water though. So water in this case is the solvent, and the dissolved stuff, the sugar in the creamer, the proteins in the milk, uh, the actual coffee from the grounds of the coffee beans. That's all. That's all the solvent. Okay, so that's number 13. All right, I'm going to pause right here, and we're going to go to number 14. 14 though looks like it's difficult. It says, what is the percent by mass of water in iron 2 sulfate heptahydrate? Whoa, it's a good one then. And so we're going to show you how to do that. And if you tried it ahead of time, great. Also, if this doesn't make sense, you can go back and try the sample problem on page 500, if you need more practice. And there's also questions 8 and 9 that you could do on page 500 that are not assigned, but you may want to do those if you're having trouble following number 14. So, so number 14, again, the question is, what is the percent mass of water in iron sulfate heptahydrate? Wow. So let me just look at the nomenclature of it. It's iron 2 sulfate heptahydrate. Now from this, you ought to be able, from this name, you ought to be able to figure out the abbreviations for this chemical, the formula for this chemical. So let's do that before we take a look at the problem. I know it tells you what it is in parentheses, but yet you should still be able to figure this out. Like iron, you probably know from our atomic zoo assignment first semester is Fe, right? Okay. And then sulfate, you may not have sulfate memorized, but remember way back when I told you that some chemistry books will take your table of common atoms, and it'll put that, it's because it's so often used, it's going to put that next to the periodic table. Well, I put a post-it on mine, and so it's on page 268. And on page 268, you have a table of common polyatomic ions, if you don't know, but sulfate is SO4. Okay, and then if you look it up, you can also see the charges on this ion, and you can see that it is sulfate. This whole thing is 2-. So because this is 2-, your iron has to be 2+. And that explains why we have that in there, that Roman numeral. So iron 2 sulfate heptahydrate. And now this is the new part for us in this chapter, heptahydrate. Hepta is one of those prefixes that tells you a number like mono, di. Mono is 1, 2 is di, 3 is tri, 4 is tetra, 5 like the Pentagon building, penta, 6 is hexa, and then 7 is hepta. So they're going to be 7 of something, and it's a hydrate, so we know that's water. So it's going to be 7 waters. And to designate a hydrate that is associated with the rest of this, and if I clean it up, it's going to be FeSO4. I'm going to put those together and eliminate those ion charges right there. To show that this water is an integral part of this molecule, we put a dot on there like that. And then we go 7H2O. Again, this is in the problem itself. If we have my finger back on page 501, I'm gonna flip back page 501, number 14. It actually tells us. Sometimes you got to figure this out though, but this time it tells you that that's it. So now that we know what the formula is, we can figure out the percent by mass of water in iron 2 sulfate heptahydrate. Okay, all right. So I'm gonna